At Fontaine Lake Camp on Lake Athabasca in northern Canada, history shows that about 30% of the guests catch lake over 20 pounds on a 4-day fishing trip, according to the source. Let X be the random variable that represents the first trip to Fontaine Lake Camp on which a guest catches a lake trout over 20 pounds. A, we're asked to write out the formula for the probability distribution of the random variable X. B, find the probability that a guest catches a lake trout weighing at least 20 pounds for the first time on trip number 3. C, find the probability it takes more than 3 trips for a guest to catch a lake trout weighing at least 20 pounds. D, what is the expected number of fishing trips that must be taken to catch the first lake trout over 20 pounds? We need to identify a successful outcome, which is a lake trout, catching a lake trout over 20 pounds in a single fishing trip to this lake. And so we need to identify what the probability of P is and Q is, since a geometric probability distribution is given to us as the formula P of X equal to P Q to the X minus 1 power. And so P is 0.30 or 30%, which is the probability to catch a lake trout over 20 pounds in a single trip. The probability of failure is 0.7. Thus, the formula or the geometric distribution that models this situation is going to be equal to 0.30 times 0.70 raised to the x minus 1. Okay, so for part B, find the probability that a guest catches a lake trout weighing at least 20 pounds for the first time on trip 3. First time on the trip number 3 translates to probability that x equals 3. In order to do this here, we need to use our calculator. Here we're going to type in P equal to 0.30, and we're interested in the value of x equal to 3. So that is going to be a 0.14700 chance if you just use cell B13, because it's the probability that x equals x value. Otherwise, you could use a table by maybe specifying, say, some cells here, 9 rows, excuse me, and then identify that when x is 3, we got that probability there. Okay, so thus we have the probability that x equals 3 equal to 0.147000. So there is about a 14% chance of catching a trout over 20 pounds in trip number 3. Okay, C, find the probability that it takes more than 3 trips for a guest to catch a lake trout weighing at least 20 pounds. We identify that more than 3 trips translates to the probability that x is less than 3, which means the probability is 4 plus the probability of 5 plus the probability of 6, or pretty much more. Okay, and so and so to get this here, this is going to be 0 point something, so we can figure this out by going this here and looking at cell. We already have 3 for the x value, so we could just look at cell B16, and so we could see that is our answer there. So 0.3400. Okay, so what does this mean? Well, this means there is a 34.3% chance of catching a trout over 20 pounds in more than 3 trips. Said differently, there's a 34.3% chance of catching a trout over 20 pounds in either trip 4, trip 5, trip 6, or in a later trip. D asks us to find what is the expected number of fishing trips that must be taken to catch the first lake trout over 20 pounds. To answer this question, we can use the formula that our expected value, mu, is equal to 1 over p, which gives us our mean equal to 1 over 0.30, because that's our probability to success, and this equals 0 or 3.33333 forever, like this. Thus, the expected number of trips to catch a lake trout over 20 pounds is 3.3 trips. I do want to point out that the expected value is also computed for you in the calculator. Here, under expected value and standard deviation, we get 0.33333. This is the standard deviation, which I didn't ask a question about, but this is basically how much on average your x values deviate from the expected value of 3.33. So on average, the x values deviate about 2.8 trips from the expected value of 3.3 trips.